This is Bob Capetta from the College of the Florida Keys, and this lesson is on domains and ranges. Just a quick reminder that for a set of points to be a function, it must pass the vertical line test. No vertical line can cut the graph in more than one point. No input can have two different outputs. So once we have functions, we're going to do some analysis to determine what the domain is and what the range is. The domain is a set of all allowable inputs, and the range is a set of all possible outputs. Domain, all allowable x values, range, all possible y values. So let's look at an example, a fairly simple one. This only has 4 points, the 0.13, the 0.25, the 0.43, and the 0.79. Is it a function? Well, if you were to graph those 4 points, you will not see a vertical line going through two of them. You do not see the same input having two different outputs. So yes, this is a function. You will notice, though, that the same output shows up twice for different inputs. That's okay. So indeed, this satisfies our conditions. If we want the domain, we're looking at all allowable x values. Well, what are my allowable x values? 1, 2, 4, and 7. So that's the domain for me. And the range are all possible outputs. What are they? 3, 5, 3 again, and 9. So the set would be 3, 5, and 9 would be my range. Of course, most functions are more interesting than just a set of 4 points. Let's take a look at this one. So we are starting here at the point -4, -3. I put a solid dot there just to emphasize that. And then I want to say that this continues. So please consider there's an arrow at the end of this graph. It continues up and to the right. And we ask ourselves, what are the set of inputs? What are the set of x values? The domain is all the possible x values, all allowable x values. Well, 10 shows up on the graph here, x value of 10. 9 shows up on the graph here. 8 shows up here. 15 will be on the graph. 100 will be on the graph. So very, very large numbers are on the graph. X of -1 is on the graph. X of -2 is on the graph. X of -3 is on the graph. X of -4 is on the graph, but x of -5 is not. There is no point when x is -5 that shows up on this graph. -5 is not in the domain. The lowest number that's in the domain is -4. So our domain are x values greater than or equal to -4. And we like to express domains in interval notation, so that's square bracket -4 to infinity. Now how about the range, y values? Y value of -1 is on the graph, y value of -2 is on the graph, y value of -3 is on the graph, y value of 1 is on the graph somewhere out here. Y value of 2 is on the graph somewhere out there. It's growing slowly, but it is growing. So the range gets as large as you want, the y values get as large as you want, but how small do they go? What's the lowest one you can use? Is -4, is the y value of -4 on the graph? I don't think so. It looks like the smallest y value that's on the graph is -3. So the smallest y is -3, so our range are y values that are greater than or equal to -3. And again, we're going to want to write that in terms of interval notation. I've made a slight error here. That should be a square bracket with -3, so let me quickly fix that. And you'll notice the change I made. That should be a square bracket, y greater than or equal to -3. So we include the -3, it gets a square bracket, and my range is y is greater or equal to -3, square bracket, -3 to infinity. Let's take a look at our next example. Again, we want to find the domain and the range. Domain, all allowable x values, inputs. Range, all possible y values, outputs. X values here, well, is 1 on the graph? It is. Is 2 on the graph? It is. Is an x value of 3 on the graph? Well, way down it will be, because we think there's arrows here where this continues. -1's on the graph, -2's on the graph, -3's on the graph, way down there. It's going to continue decreasing forever. So all x values at some point would be on that graph. It may take a long time to get there. But my domain, I believe, includes any possible x value you could think of. If you drew the graph large enough, you could see that the x value would hit. So my domain is all real numbers, -infinity to infinity. Range, y values. Negative 5 is on the graph twice. Negative 4 is on the graph twice. Negative 3 twice. Negative 2 twice. Negative 1 twice. 0 twice. 1 twice. 2 twice. 3 is on the graph only once. 4, the y value of 4 is not on the graph. So 4 is not on the range. 4 is not a possible output. 4 is not a possible y value. So the largest y value I can use here is 3. So my range would be y values that are less than or equal to 3, which in interval notation would give us round bracket negative infinity to 3. Okay, let's take a look at this graph and let's make sure we're clear on what it represents. Arrow going this way, and then this red line is coming down. It's an asymptote. It's getting closer and closer and closer to the y-axis without ever actually touching. And then we ask ourselves, what are the possible inputs? What are the possible outputs or allowable inputs? X value of 10 is on the graph. X value of 9 is on the graph. 8's on the graph, etc. X value of 2 is on the graph. X value of 1 is on the graph. X value of a half is on the graph. A quarter is on the graph. A third is on the graph. Negative 1 is not on the graph. Negative 2 is not on the graph. This is asymptoting. It's getting closer and closer to the y-axis without actually touching it. If it never actually touches it, 0 is not on the graph. But anything bigger than 0 is. Therefore, our domain for this problem will be x values bigger than 0, which will be 0 to infinity. Now, how about y values? Y value of 3 is on the graph. 4 would be on the graph if you go out beyond. 2 is on the graph. 1 is on the graph. 0 is on the graph. Negative 1, negative 2, negative 3, negative 4, negative 5. And this goes forever and ever and ever and ever, getting closer and closer to the y-axis without ever touching it. So all the negatives are on the graph. All of the positive y values would be on the graph if you extend it far enough. So the range on this is all real numbers, all possible y values. So in interval notation, we would say from negative infinity to infinity. Let's take a look at the next case that we have. Interesting looking function. Which x values appear on the graph? What are our allowable inputs? 11 is on the graph. 10 is on the graph. 9 is on the graph. 8 is. 7 is. 6 is. 5 is. 4 is. 3.5 is. 3 1/4 is. But 3 is not. There is no dot for 3. 3 does not show up on this graph. 2 is on the graph, 1 is on the graph, 0 is on the graph. It looks like every x value is on the graph except for 3. And indeed, that's our domain. All real numbers except 3. So we're going to remove that. In interval notation, that would be minus infinity to 3 union 3 to infinity. Now how about the range? Y values. Is 5 on the graph twice, 4 on the graph twice, 3 on the graph twice, 2 on the graph twice, 1, 0, negative 1, negative 2, negative 3. Negative 5 is not on the graph. Negative 5 is not in the range. So what's happening at negative 4? Negative 4 is another one of those asymptotes. The graph gets as close to negative 4 as you want without ever actually getting there. So negative 4 is not on the graph, but anything bigger than negative 4 is. So our range will be y is bigger than negative 4, round bracket, negative 4 to infinity. Our next graph does not have arrows on the end. This one we thought it extends like in this direction forever, it extends in this direction forever, it extends in these two directions forever. This next example begins and ends. I have the dots there to clarify that. We have to ask ourselves, what's the domain, what's the range? What are all of my possible x values? Well, let's see. 5 is on the graph, 6 is on the graph, 7's on the graph, 8's on the graph, 9's on the graph, 10 is not. 10 is not in the domain. 3 is on the graph, 2 is on the graph, 1, 0, negative 1, negative 2. But negative 3 is not in the domain. But it appears that all of the x values between negative 2 is the smallest one I see, and 9 is the largest one I see. All of the x values between negative 2 and 9 are represented on this graph. So my domain is x is greater than or equal to negative 2 and x is less equal to 9. So square brackets negative 2 to 9. Similar argument for the y values. You'll notice negative 5 does not show up on the graph. Negative 6 as a y value does not show up on the graph. But negative 4 does. How high does it go? The highest y value on the graph is 6. Some of them are there twice, like you'll notice 4 is on the graph twice, 3 is on the graph twice. But the lowest y value I see is -4. The highest y value I see is 6. So my range will be y's, not x's, so that's a typo. Y's between -4 and 6 is what we should have there. All right, our next example, what's happening here? Interesting looking function. Arrow up here, so this goes forever. Arrow down here, that goes forever. What are all of my allowable x values, and what are all of my possible y values? X values. Is -8 on the graph? Yes. -7, yes. -6, -1, 0, 1. 2 is on the graph. 3 is on the graph. Here, 4 is on the graph if you extend it up, as is 5, 6, 7, 8, 9. So I think all of the x values are fair. All of the x values will show up on this graph. So our domain would be all real numbers from -infinity to infinity. Range y values, which y values show up? 7 is there, 6 is there, 5 is there, 4 is there, 3, 2, 1, 0, -1, -2, -3, -4 shows up on the graph. -6 does not. -6 is not in the range. This is an asymptote, so it gets as close to -5 as possible without ever actually touching it. So -5 is also not in the range, but anything bigger than -5 is. So our range here would be to say that y is greater than -5 or round bracket -5 to infinity. And here is our last graph we'll look at. This is just a line. Arrows going that way, arrows going that way. Every x value here shows up. You can see it on the graph, but it extends. So all the negatives show up here, all the positives, x values like 9, 10, 11 would be on the graph somewhere. So my range is indeed all real numbers, -infinity to infinity. Excuse me, my domain is that. My range, 7 shows up, 6 is there, 5 is there, 4 is there, 3 is there, 2 is there, 1 will be there, 0 will be there. If it extends out, -1 will be there, -2 will be there. The range, the y value is also everything. So our range is also all real numbers from -infinity to infinity. So it's important to be able to look at a graph to determine your domain, all allowable inputs, and your range, all possible outputs. But I also like to look at functions. So if we're not going to look at this graph, can we at least determine the domain? Range is a little harder without a graph, but the domain, all allowable inputs. You know you cannot divide by 0. So if we want the domain, the denominator, the bottom of the fraction cannot be 0. X plus 4 cannot be 0, which means x cannot be -4. So we've got to remove -4 from our number line. So from -infinity to -4, remove -4, and then from -4 to infinity would be our situation. So we go ahead and add that. And this is what the interval notation would look like for removing -4 from the number line. Next up I have g of x is 5 over x minus 2x minus 7. Again, the bottom cannot be 0. So if either of those is 0, the entire bottom is 0. So to find the domain, x minus 2 can't be 0, x minus 7 can't be 0. So x can't be 2, x can't be 7, so remove 2, remove 7. In terms of our number line, -infinity to 2, together with 2 to 7, together with 7 to infinity. And write those union signs in between, so that our interval notation answer would be -infinity to 2, union 2 to 7, union 7 to infinity. Okay. Next up, I have k of x is the square root of 2x plus 10. The thing to remember here is that you cannot take a square root of a negative number. Square root of 9 is 3 because 3 times 3 is 9. Square root of -9, what times itself is -9? Well, there is no such real number. We need to go to the complex world to do that, and we're not studying complex valued functions. So from our perspective in this class with functions, the thing under the square root cannot be negative. So if I'm looking for the domain, I've got to say 2x plus 10 has to be greater than or equal to 0. Now if I'm going to solve this as an equal to 2x is -10, x is -5, and then test numbers on each side, if you go to the right of -5, plug in 0, 2 times 0 is 0, plus 10 is 10. That's bigger than 0. So we're going to click to the right. X is going to be greater than or equal to -5. So in interval notation, what will that give us? It'll give us square bracket, -5 to infinity will be the domain. You might be able to think of the range on this one too. The smallest that this ever could be is 0. So your range would be square bracket 0 to infinity. Although for many of these problems, a graph certainly helps finding the range. That will conclude this lesson.